Hello friends, welcome to Knowledge India once again. In this particular tutorial, we are going to talk about Amazon Aurora. This is a fully managed relational database from Amazon. And why is it different? What all does it offer really? We'll try to talk about all of that. We will see that what advantages or what new features does it bring. We'll also try and understand that how do we go ahead and create an Aurora cluster from scratch? What are different types of endpoints which are there in that? What mechanism does it use to basically enable high availability for you? What is the concept of replicas in Aurora? What are cross-region replica and all such things, right? So we will be covering uh, a lot of concepts in this session, and along with that we will also look at demo. Okay, so I highly recommend that you also go ahead and try the same in your account, because once you have done it, you know you will feel confident, right? So we will move forward, and I'm sure that you have seen our other video on RDS already. So you have an understanding of Amazon RDS service, which is a relational database service. You have an understanding of that, right? Now within Amazon RDS, we have got Aurora as well. And in this particular session, we are going to concentrate more on Aurora. Okay. If you have not watched the RDS video, I will request you to go ahead and watch it first and then come back to this particular chapter. You can find the link in the description below, and you can go ahead and watch the RDS video. About Amazon RDS. So as we all know that RDS offers us 6 different types of database engines. If you see on this particular slide, what we're talking is that RDS gives you things like SQL Server, Oracle, which are commercial engines or commercial databases. There are also open source databases like PostgreSQL, MySQL, MariaDB. In addition to that, you know, Amazon offers something called Amazon Aurora. Now, Amazon Aurora has got a lot of new features which you would not be able to find in other relational databases, right? So we will talk about all those features as we move forward. But one part I hope all of you understand and you are clear is that when you go with a managed database service or a managed database solution, you as a customer, do not need to take care of so many operations, right? If you go with the infrastructure as service option, where you go ahead and create your own VM or EC2 instance, and then you go ahead and install a database on it, you end up doing a lot of activities, right? Right from backup, applying patches, any other routine maintenance which you need to do, all of that thing becomes your responsibility, right? Whereas when you use a managed service, you are free from all of that. So you just create your database in a matter of few minutes, and then you can just start using it. Give it to your developer, and your developer can start creating the tables, etc., start writing your queries. So you concentrate on the application development part and not on managing the database part. That's the advantage of RDS. So now, whatever I talk now, this is common thing among all the RDS engines. Now, within that, Amazon Aurora is a bit special, right? Of course, Amazon has put a lot of engineering, in bringing this particular service. What's the key thing with Amazon Aurora? With Amazon Aurora, it is promised or it is offered that you get an enterprise scale database or an enterprise grade database at the price of open source database. So of course, open source databases do not apply a very high license cost, and that's why they are cheaper. But then when big enterprises want to select a particular database to use in their organization, they end up going to these commercial databases like Oracle, SQL Server, etc. But then Oracle, SQL Server, these databases have a very high license cost, and that's how that makes the overall spending on database really high. Now what Aurora does is Aurora gives you the same type of performance as you would go ahead and get with Oracle or SQL Server, right? Great performance, but the cost is a lot lesser. Also, it it is available to you as a fully managed service. So you do not have to worry about lot of operations. And when I say fully managed service, the reason why I'm saying that is in case of Aurora, it would manage more activities than any other RDS engine. That's the important thing. And as we move forward, we'll try and understand that what are those um, special features which are available with Aurora. So stick to this, watch this video completely, and also go ahead and do the practical along with it. That's really important. All right, so it is delivered as a managed service. We talked about all of this, which is written on the slide. An important thing is currently Aurora supports, or we can say it is compatible with two databases like MySQL and PostgreSQL. Why is it important? It's important because if in case you are using uh, or you have an application, let's say, which currently uses MySQL or PostgreSQL, you do not have to worry when you go ahead and switch to Aurora because all your queries which are written in your application would be perfectly compatible with Amazon Aurora. Of course, there are some version level thing which you need to check. Uh, Amazon keeps working and tries to make sure that more and more versions of MySQL and PostgreSQL would be compatible. So I suggest that you can always look that particular value in the documentation. But the point is, MySQL and PostgreSQL are supported. So your existing database developer who understands MySQL or PostgreSQL can go ahead and work very well with Aurora without much learning curve. And of course, in terms of pricing, it is pay as you go. So as you use, you pay on-demand pricing. Of course, RDS also supports reserved pricing. If you have visibility of your workload, you may go ahead and get benefited with reserved pricing. Okay, so I think what we would do now is we will go ahead and see a quick demo of how do we launch uh, Aurora cluster and then how can we connect to it. And while we go ahead and launch the Aurora cluster, in that demo we would be able to see many of the properties of the Amazon Aurora database. We will come back here and we'll talk about few more things from our slides a bit later. All right, so let us go and watch the demo. Okay, so as you can see here, I'm logged into my Amazon console. I'm there in the RDS dashboard. Currently, there is no database running. So what I will do is I'll go ahead and first quickly create Amazon Aurora cluster. So I'll go ahead and say create database. I highly recommend that you should have watched our RDS video before watching this because many of the things related to RDS we have explained there. So I would not uh, try to repeat those stuff again here. Okay. So so there are, these different engines. We can go ahead and choose Aurora and move forward. But before I do that, I would like to just do one thing quickly. Uh, I'll go ahead and create a subnet group. So let me just open the subnet group in a new tab. I'm not going to create a custom VPC. I've already explained all of that in the RDS video. So you guys, if you have been watching our videos, you know our standard VPC, how to create a VPC from scratch and all such things, have public and private subnet within that. If you have not watched all of that, I request you to go ahead and watch the VPC video and the RDS video, and then you can come here. Okay, so that you are clear with it. So what is subnet group? DB subnet group. DB subnet group basically specifies a collection of subnets. So it guides RDS that in which subnets you should go ahead and launch your instances. So I'm just going to create a new subnet group. I'm going to call it, let's say, demo sub group, demo subnet group. I'll just put the same thing here and choose the existing VPC. Now in this VPC there are three different availability zones, or we can say three different subnets are there. So I'll just go ahead and choose only two, just to make it different from the default subnet group. I'm choosing only two subnets which belong to 1A and 1B availability zone. We'll just go ahead and say create. So what does this mean? When I go ahead and launch my Aurora cluster, and I'll be choosing demo subgroup as the subnet group, the instances of the Aurora database would get launched only in the two subnets which are part of this subnet group. That's how you control it. Okay, and of course when you say subnets, every subnet belongs to an availability zone. So it's highly recommended that the two subnets which you choose should belong to two different availability zones. All right, I'll go back to databases here. We'll go ahead and say create database very quickly. Go ahead and choose Aurora. As you can see, when you choose Aurora, you have got 5.6 MySQL compatible. In this, you have serverless option. We will explain serverless in a different video, so don't worry. Currently, in the normal method where you will have servers, you have got MySQL 5.7 and PostgreSQL as well. So whichever you want, you can go ahead and choose. Doesn't make much difference. So we'll go ahead and select one. We'll say next. We have chosen the provisioned type, or basically the non-serverless type, right? So as we said, serverless will catch up later. You can go ahead and choose which MySQL specific version do you want, what would be the DB instance class, how big do you want to keep it, just demo, so we'll keep it small. Now next thing is multi-AZ deployment. Create replica in different zone, yes or no. Now some of you would have read about Aurora before, and it would give an impression that when you create an Aurora cluster, by default things are available or things are copied in different availability zones, and that might give you an impression that you don't need to create multi-AZ deployment. Please let me explain this to you. In case of Aurora, yes, it is correct that the data gets copied by default to three different availability zones in the region, right? So, and in every availability zone, two copies. So basically 6 copies of data gets created, but the instance would be only one. Okay. So you understand that in order to run a database, you would need the instance as well, right? You need CPU, RAM, then only it would work. So the instance would be only one. Now, if you want that two instances should be running in two different AZs, then you need to go for yes option or multi-AZ deployment option here. Okay. Now the terminologies are a bit different, and please do not get confused. I want to explain it to you here. When you launch a normal RDS database, be it MySQL, RDS MySQL, RDS SQL Server, or RDS Oracle, you get a multi-AZ option there, and if you say yes, there are two instances which would be launched, right? One out of that would be primary, one and the other one would be secondary. You do not get to see that really, but the point is one would be primary, another one would be secondary. There would be a synchronous replication between the two. Okay. Now, but what happens in case of Aurora is that you will have a master instance, and then you will have a replica of it. Now the replica only supports read operations. Master or the primary one would support the write operation and read operation both, whereas the replica would support only the read operation. It will become more clear as we move forward, so just be with me. Understand that I'm going to say that yes, I want a replica in a different zone. So basically I want another instance which should be running in a different availability zone, so that if something happens to my primary instance, or let's say something happens to the availability zone where my primary instance is running, no problem, Aurora would automatically switch to my replica, which is there in a different availability zone. Okay, so let us move forward. I'll just leave it yes, and you will see its effect just in a while. We need to give some instance identifier. Um, all right, so let us just give some DB instance identifier. I'll call it demo Auro instance. A master username, it should be 1 to 16. Okay, must contain 1 to 16 alphanumeric characters. So let's call it Auro master, or just to okay. So we'll say next. All right, we are going to of course launch it in our default VPC. We'll choose the subnet group which we created. Next is the public accessibility. All of us understand that we should not keep our databases public. That's why no is selected by default as well. So please don't make your databases public, right? So we'll keep it no. So what does it mean? The instances which will get created as part of this cluster would not get any public IP. Availability zone preference. Do you want to give an availability zone preference? If you want, you can go ahead and give that. Choose the availability zone from the current region in which you want the DB instance. Availability zones provide high availability. This is all really general concept. You can go ahead and just skip that. If you go ahead and choose something, that's fine. What would happen is master would come up in this particular AZ, and then replica would get created in the other AZ, which would be available as part of your subnet group. Please see that we are only getting those two availability zones for which we had chosen the subnet in our subnet group. We are not getting 1C here. All right, we'll just say create new VPC security group. That's fine. Cluster identifier. We can go ahead and give some name. Let me call it Auro Cluster. DB name inside, I'll call it Auro DB. Port, you can give whatever, because we chose MySQL, it is 3306. Parameter group, cluster parameter group. We have talked about these things. These are basically sets using which you can go ahead and pass certain values, for different settings. We have talked about this in our previous video. If you want, you can go ahead and create custom parameter group and custom cluster parameter group as well. You can enable encryption as well. You can go ahead and just choose which key do you want to use, and you can enable encryption. So understand, when you enable encryption, from your application level, you don't need to change anything. Database or this particular service will take care that while the data gets stored onto the disk, it is encrypted, and while you query and get data gets presented to you, it is decrypted. So if you want, you can go ahead and enable that as well. For now, I'm just saying disable. Failover. Now this is an important one to understand. You see, we have got a lot of these values like tier 0 to tier 15. Why is it there only up to tier 15? The reason is, in case of Aurora, it allows up to 15 replicas for a database, or for a cluster. It allows 15 replicas. So this particular value, priority, kind of sets the priority of a particular Aurora DB instance, so that in case of a failover, which particular replica should become master, that gets decided based on this priority value. Okay, so for example, if I have got one master and let's say two replica, okay, just for an example, if I've got one master and two replica, I would based on my requirement or planning, I will go ahead and say for the first replica, I might go ahead and say tier 2. For the second one, I might say tier 3. So in case of a failover, the first replica would become master because it has got a higher priority. So you need to understand that, as in terms of rank it happens, even in case of priority, tier 0 is higher priority and tier 15 is lowest priority. Um, somebody somebody might question that in case two replicas have got same priority, then what would happen? In that case, uh, RDS will try to compare that which replica has got the same configuration, same sizing, same configuration as that of the master, which got corrupted or which failed just now, and whichever has got the same configuration, that particular one would be promoted as master. If that is also same, then it will just pick one. All right, backup retention period. We understand the automated backups which happen for how much duration it would be there. Monitoring you can enable enhanced or normal monitoring. If you do enhanced, you can go ahead and basically monitor at a really granular level. You also have option to export logs, different type of logs. You can export it to CloudWatch logs, and once it is there in CloudWatch log, you can go ahead and create filter and then basically create alarms as well for any situation for which you want to get alerted. We have a different video where we have explained how to use CloudWatch logs, right? So you can go ahead and watch it. You'll understand how to create filter and alarm on that, those things we have explained. So there are different types of logs: error log, general log, slow query log, audit log, all such. Check these and this would be pushed to your CloudWatch logs. AutoMiner version upgrade, you can enable or disable it. Maintenance window, you can specify enable deletion protection. Very simple. If it is enabled, you cannot delete the cluster. So that's what it is. Go ahead and say create database. Once it gets created, there would be a lot of things to add. That's great. So as you can see, our Aurora cluster is ready, right? It got created. Now, if you have created Aurora cluster for the first time, you would see this type of, hierarchy which shows up here. You would not see this in case of, in case of RDS, at least in the older dashboard, it was not there. Now, you can see that we gave a cluster name, so that is appearing here, and then there is this is the name of the instance which we gave. So this is basically our master or primary instance, and a reader or a replica got created, right? So it automatically got named in this way. Now the point is, let's go ahead and look at some of the properties. Before we do that, if you scroll to right, you will see that there will be delay mentioned, but I'm not getting to see that. Okay, just go and say replica lag. Okay, so here you see between the replica and the master, there's a lag of 20.034 milliseconds. So it's really less. So 20 milliseconds is what is there. So anything which you write here would be available onto your replica after 20 milliseconds. Now, if you click on cluster and look at its properties, there are a few important things. So you can see that your cluster has got two endpoints. This is always by default, cluster will have two endpoints. So you got a reader type of endpoint and a writer type of endpoint. And you need to understand that if you connect to the writer endpoint, then you can execute both read and write type of queries. Whereas if you connect to the reader endpoint, then you will be able to execute only read type of SQL queries. Okay. Other than that, these things are common, so I'm not gonna kind of go through all of this. The important part is if you go ahead and click on individual um, uh, Aurora DB instance, you will see their individual endpoint as well for this one and for this one, right? There is difference. But uh, what I wanted to show you was, if you see the endpoint for the cluster, you see this part is same, Aurora cluster dot cluster hyphen RO. This is the difference. So RO means this is read only. So that's the reader one. Whereas where there is nothing written like no RO or anything like that, that's the writer endpoint. In addition to this, we can also go ahead and create custom endpoint. I'll just explain you custom endpoint, but before doing that, it would be great if I show you how to create further one more replica. So let me go to actions and I'll say add reader. Okay, add reader is just like adding one more replica, which will be there in the same region. So you can see master has the writer role, whereas the replica has reader role. We can also go ahead and create cross region read replica in case of Aurora. That's beautiful stuff. So if you want to, if you may have a scenario where your master database is running in, let's say, US East, and you also have your office has got uh, many of your executives working out of, let's say, Singapore. You may go ahead and create a cross-region read replica so that a read replica is placed in the Singapore region, and the part of your application which generates all the reports, right, which continuously queries against the database and just generates the reports, or that particular module can hit the read replica which is created in the Singapore region. Okay, so that way very less latency. Also, in case of any disaster, you may go ahead and promote the read replica which is there in Singapore to become the master. Okay, that's possible, and just few button clicks. Anyway, so let me go ahead and say create add reader, and then the same stuff. I can go ahead and choose that in which availability zone do I want to keep it. What will be the size you can change as well. So for example, I can go ahead and make this one as a bit bigger if I want. Replica source from where it will take. So I may go ahead and keep the source as my master or another reader, so that way my master would not be further loaded. In a way we can do that. DB identifier, a preference, maybe for this I'll give tier 3. Monitoring, etc. If you want, you can go ahead and do that, and then say add reader. So as you can see, one more reader is getting created. So let it get created. In the meanwhile, let's quickly talk through different endpoints. That's really good. So as you can see here, there are 3 types of endpoints. So the first one, which we already talked, the cluster endpoint, or basically the one which supports writing, right? So I mean, of course, it supports writing and reading both. You can use the cluster endpoint for all write operations like insert, delete, etc. You can also use the cluster endpoint for read operations such as queries, I mean select queries. So in this case, if I select this cluster, this one is the cluster endpoint or the writer. Okay, that's the, you can either call it cluster endpoint or you can call it the writer type. Then there is a reader one as well. What's the use of reader one? A reader endpoint for an Aurora DB connects to one of the available Aurora replicas for that DB cluster. Okay, each Aurora DB cluster has one reader endpoint. If there's more than one Aurora replica, the reader endpoint directs each connection request to one of the Aurora replicas. This part is really important, because with this, what's happening is your reader endpoint is kind of acting as a load balancer, right? So that's the reason why I try to create another reader as well. So what happens is, now that I'm gonna have 2 readers, if I go ahead and basically send any query to this particular endpoint, which is RO, right? What would happen is internally it will distribute the load. It will send one query to let's say this reader DB002, another query to this next reader. It will do that. But it is recommended that normally, uh, you know, uh, the instances which are behind this reader endpoint should be of same size. But in our case, it's different. So if you have one such scenario, you may also go ahead and create a custom endpoint. Okay, let me show you that. So I'll go ahead and say create custom endpoint. Now I can go ahead and give some name which I like. Let me call this reporting, right? Reporting dot this. And then I can go ahead and select out of all my instances, which instances do I want to make part of this particular endpoint. I'll just repeat it once again so that you are not confused. Let's say you have got one master and you have got 5 replicas, right? Out of these 5 replicas, let's say 3 are of one size, let's say T2 medium, and 2 others are T2 small. Now, if you want that traffic, a certain reporting type of traffic should come to those 3 replicas which are of T2 medium size, then you can just go ahead and select those in this area, right? So the idea is that while you are creating a custom endpoint, keep the keep those replicas which are of same size. I mean, it would not stop you if you go ahead and keep different size replicas as well. But in terms of the overall load balancing, that would not be very ideal, right? So it's up to you. You can go ahead and select any of these. Now, please understand that the writer or the master instance which is there, that supports reading as well. So that's why it allows you to select it here. But of course, if you have got replicas available, it would not make much sense to include the writer here, right? So it's up to you. So you can go ahead and select the other two, or if you have more replicas, you can select any number out of that. Select it, just go ahead and say create endpoint. You also have this feature attach future instances added to this cluster to this. So if you tick this, what would happen is any new instance or any new reader instance, if you add in this cluster, automatically it will get added to this endpoint. So it's up to you if you want to do that. If we go ahead and just say create endpoint, it will start creating a new custom endpoint. So this is again a really, really powerful feature. So think of a scenario where you have got a really big database. So you have got a master, and then you have got, let's say, 10 replicas. Out of that, 3 are of one size, 4 are of other size, and 3 other replicas are of some other size. So you can go ahead and create 3 custom endpoints and use one custom endpoint for one particular purpose. Okay, so that was around the custom endpoint. In the meanwhile, what I did, I also went ahead and just created an EC2 instance so that I can just connect and show you that that we are able to reach the database. Of course, post that executing the queries. I'm not gonna demo that. I hope you guys know that already, how to query database and so on. So we will just go ahead and quickly correct our security group. It has only one IP allowed now. Okay, so as you can see, I just edited the security group and opened the inbound a bit wide open, right? So, I mean, of course, in case of your application, you can go ahead and specify the CIDR as your web servers subnet or whatever you like. For now, I've just opened it wide. And now we'll go ahead to the EC2 instance and we'll just try to uh, connect to this. So I already have Telnet installed on this machine. Uh, right, so we'll just go ahead and try to do Telnet. And let me go here and I'll try to pick this particular and 3306. You can see it got connected, so the cluster is reachable. Good. So we got the cluster created. You have uh, the read-only endpoint. You have your master or writer endpoint as well. So within your application, you can go ahead and configure these endpoints as and where it is relevant. Uh, Now let's go back to few more concepts. I will just quickly finish it off. So what happens? We kind of talked that in case of Aurora, first of all, it really gives you high performance, and that's because for the storage only SSDs are used. In addition to that, whatever data you know is getting written, it gets copied into 3 availability zones and 2 copies in each availability zone. So it supports it supports high availability in such a manner that even if a full AZ goes down, you will be able to you know you'll be able to have your instance up and running. If you want to understand the whole quorum part, I'll just leave the link in the description. You can go ahead and read the link in the description. One of the points which I wanted to tell you was this around having replica. So one may go ahead and choose that I will not have any replica, right? If you remember, while we were launching the instance, we had an option whether you want multi-AZ deployment or not, right? So if you say no, what would happen is only one master instance will come up. Even in that case, the data would be getting stored in 3 different availability zones. So what happens if the AZ in which your master instance is there that goes down, or something happens to your master instance? What would happen? Aurora would handle it in such a way that because your master has gone down, it will launch another instance, okay, on its own in a new availability zone, and the storage is already available, that gets attached, and your DB is available again to work. But please understand, in order to launch this new instance, it will take some time, and hence your application will face service disruption, or DB would not be available for some time. Okay, if you don't want that to happen, you want that in case something happens to your master, within few seconds your DB should be available again. You should at least have one replica. It is, in a way, it is same like multi-AZ concept in that, in case of RDS. Just that in case of Aurora, you get separate endpoints for both the instances, for the master instance and for the replica instance as well. Whereas in case of other, normal RDS, if you go, you just get one endpoint for your RDS. That's it. All right, so I hope you understand that part. Some additional new things with Aurora, which is not there with other RDS engines. You can go ahead and invoke Lambda function from your stored procedure, from Aurora. You can load data directly from S3. You can, of course, take DB snapshots and etc. and keep the backup in S3. You guys know all of that. One really great feature is having an ability to allow an IAM user to come and operate at your DB level, right? So if you have read about DynamoDB, you understand that in case of DynamoDB, you use an IAM user to go ahead and operate or do things, either IAM user or IAM role, basically. There is nothing like DB level users, right? And that's a very great thing, because in that case, you will be able to control all the users from one place. Now, in case of Aurora, it is possible. It's not possible in other relational database or other RDS engines, but in case of Aurora, it is possible. You can allow IAM users to go ahead and operate at DB level. I will make a separate video where I'll show you completely how to do that. Step by step, I'll show you as I showed you a demo now. You can also, of course, upload metrics and logs to CloudWatch. I think we understand this one already. You only need to worry about your schema design, your tables and other stuff. You don't need to worry about monitoring, increasing the storage and all of such things. The good thing with Aurora is you never have to specify the storage, right? It's not that like other RDS engine, you have to say, I want 500 GB or I want 200 GB. No, you can just go ahead and create your cluster, start storing your data, and automatically the data allocated to your cluster keeps increasing in chunks of 10 GB. Okay, right? When it is about to be filled, it keeps increasing. So it's not your headache to go ahead and increase the storage at regular intervals. It's not your work. Why people are moving to Aurora? Of course, the cost is less, right? In addition to that, the performance is really really good, right? If you compare it with other engines like MySQL or PostgreSQL, the normal engine, open source, Aurora gives a lot better performance. There are detailed decks which are available on internet where you can go ahead and compare the performance, but it's really good. Many times it's better or faster. And in terms of cost, if you compare with the commercial databases, it's lot lesser. There is very proper monitoring via this console, as you saw, via AWS console, and also there are tools available to migrate data to Aurora. If you are using some other database and you want to migrate to Amazon Aurora, you have got tools available like DMS and SCT. DMS is Database Migration Service, which is from Amazon, and SCT is Schema Conversion Tool. So DMS basically helps you to dump data from a source DB to a target DB. It can be homogeneous and heterogeneous both, right? So there are different heterogeneous combinations which are possible by DMS as well. It also supports live data migration, right? SCT is when you want to move from one database type to another, right? You would want to actually understand that what all tables will get converted as it is, what like if there is a compatible data type, then table definition can be changed. There would be few things which cannot be changed, right? So SCT tool basically does that analysis and gives you a report, and then based on that report you may plan your further activities. I'll try to do a separate video on SCT, but the point which we are trying to explain here is there are options available, proper documentation available, that how can you go ahead and move your data from Oracle or SQL Server to Aurora. Okay. Schema conversion automation from Oracle and SQL Server to Aurora is over 90%. So a good amount would be automatically changed. While if you want to put data to Aurora, you can also use the native utilities like pgdump in case of PostgreSQL. In case of MySQL, you can have the dump file or the backup file itself and basically restore an Aurora cluster from that. It's possible. We already talked about it. So the way Aurora works under the hood is that it maintains a quorum, and based on that it gets decided that on which AZ the new master should come up and it should not get corrupted. There is a detailed article on that. I'll leave the link in the description. You can go ahead and read it if you want to understand how the whole quorum works. Okay. In terms of custom endpoint and the read replica, we already talked about this. So there will be a master instance. There will be replicas, okay, and you can also, so there will be reader endpoint. You can also go ahead and have custom endpoint, as we talked about. Up to 15 read replicas you can create across different availability zones. Redo log based replication leads to low replica lag, typically less than 10 milliseconds. So we saw that it was 20 milliseconds, but then it differs a bit, but then normally 10 to 20 is what you will get. Cross region read replica, we quickly talked about it. It's possible that you can have your master in one region and read replica in the other region as well. In case of your master region going down, let's say US East goes down, that should not happen. But in case it goes down, then you may go ahead and make the read replica which is there in your Singapore region as the master. That's possible. You can promote it. So if you want to take or understand that how much time does it take in case of cross region, then even that is really fast. If you see less than 1 second across cross country read replica lag under heavy load, which is less than 1 second. That's also really good. And within a minute you will be able to, send all your workload in case of a disaster. You will be able to redirect all your workload or queries to the read replica which you promote to master. Okay, like if you have the example which we talked, let's say USC goes down, you make Singapore as the master or promote it to master. In a minute you can actually shift all your workload there, which is kind of really good, considering the distance between two regions and all of that stuff. So that's good. um, a quick thing additionally here. uh, So any database node which fails or something goes wrong, it would be repaired or kind of replaced. Like it will be flushed and a new one would be created, right? Uh, Secondary nodes automatically promoted on persistent outage, no single point of failure. So this part we talked already. If you have a master and replica or replica is what we call here, so you don't have to worry. Automatically, other one would become master. And other things, customer application can scale out read traffic across secondary nodes, so or basically across multiple replicas which are there. So you can do that via hitting the reader endpoint, or you can go ahead and create your custom endpoint as well, right? We talked about load balancing across different replicas, which is done by the endpoint. We talked about that as well. So that was an overview of Aurora service. I hope you understand that how this particular service works, what all features it brings, and understand, guys. Just to summarize, what happens is you do not have to worry about the sizing, etc. Right? There are a lot of options to, of course, scale out, by adding read replicas. But please understand, in case of relational databases, if you want to do vertical scaling, it always involves a stop and start. That part doesn't change. But then with Aurora, you get rid of things like storage management, planning for all of that, very fast replication between your master and the replica. The cost comes down. That's really good. So all those features are there with Amazon Aurora. I hope you liked this video, you understood. I request you to go ahead and do hands-on. We will have more videos on Aurora showing you further advanced things within this very soon. Please help us by sharing this video with your friends, colleagues, in case you liked it, and you can subscribe to our channel to watch more such videos. There are a lot of videos already there, arranged in the form of playlists on our channel. Go ahead and take a look at it. Till we meet next time, bye bye, take care, study well, practice a lot. See you guys, bye bye.